Given the graph of this below, determine the equation if this has happened. Okay, what do you want to do with this first? What do you physically want to do? Reflect it? How so? Which axis? Over the x? Okay, so I'm going to change let's just pretend that line is right at -3, by the way. You know how hard it is to draw these things? So instead of -3, it should be at a height of +3. Oh, and that's it, right? There's nothing else that happened. Okay. So that is, where am I going to put that negative? Did you put it in the A position? Okay, number 8 and 9, it's the same graph. The first time you're reflecting it over the y-axis. So that means B is negative. And then on the second time, I'm reflecting it over the x-axis. So A is negative. Okay, so why is it going to look different? So that's a B negative. And this is how you would do an A negative. Do you see a difference in the format? An A is out front multiplying your whole function like that, versus a B just negates your x part of the function. Okay, let's graph both. Does anybody know? Does anybody know what that just looks like from grade 11? It's a shape of a parabola with a y-intercept of 4, and it's heading in which direction? Heading downward. Okay, so if I reflect it over the y-axis, what will happen to it? It's the same. You see it? Nothing's going to happen to it. For instance, this coordinate is just going to flip-flop to that side. That's just going to flip-flop to that side. Nothing's going to happen to it. Okay, what will it look like if you flip it over the x-axis? So that will look a little different, right? Instead of opening downward, it will flip and open upward. Oh, I did a lot of pages here. Okay. Do you like this? Do you want me to keep going? I don't know. I'm trying to like really get this into your brains. Okay. What point would be invariant? So, if I reflected it, if I changed, this is changing the y, which coordinate would not move? Am I on the wrong page? This is the right page? Which point would not move? There's one point that would never move. If you were to reflect it over the x-axis, which point is not moving? 4, 0. Or 5, what is it? This is weird.
5, but it's on 4, 0.
4, 0. Why is that there? We're just going to go like that. I'm not sure what's going on. Oh, I think they're saying like 1, 2, 3, 4, 5. Well, let's just call it like that though. Okay. Now, if you were to change the x or flip it this way over a y-axis, which point wouldn't move? It's thinking about which point it would kind of swivel with. That coordinate, right? Wouldn't move. Everything else would flip. So 0, -4. Okay, describe. So describe means to do what on your answer? Words. What do you see happening? The solid is the first one, and then it went to the dashed. So what happened to the solid one? Reflect over x-axis, and then it, what else? It shifts left, I think 3, right? Okay, solid was the starting, and then we ended up with the dashed. What did we have? What happened here? Those coordinates are not the same pattern away from each other, right? What do you want to say happened? A vertical stretch by a half? Or what's another way to physically say that? Vertical compress by 2. Those are the exact same language. Do you see it? This is like 2 away, and now they got smushed together. And then what else has happened? Shifting up 3. Okay, write the dashed line in terms of the solid line. Okay, so we start at the solid line. This is our F, and then we turned into that. Okay, what do you see physically that has happened? Reflection. So that has happened, and that kind of reflection makes what negative? The A or the B? Pick the A. What else do you see has happened? Is there any more stretching or compressing? I'm going to look at this. So this to this was kind of like a 1-and-1 move. Oh, that's not the same kind of pattern. What maybe has happened? I'm stretching the points away from each other. So that's an A of 2. And now we can go into our shift mode. I think we're done with that stuff. We have shifted left 2. Okay, so g of x equals the f of x with all of those things that have happened. Okay, next one. Oh, okay, this is our original, this is our new. What has happened here? Do you visually see anything? It is reflected. I see a reflection. So that's an A reflection. And then it has, I think it's kind of the same shape, right? Does anybody see any different kind of shaping? And then it's moved left and up. So count how many that is. So move left. Did you know how many? Anybody? 3. And then I think that's also 3 up. Okay. Give me a math coordinate here. Math coordinate using the negative, the 3, and the 2. Okay, we're good with the math coordinate? So every point needs to move somewhere. I got 3 points there that I've picked. So 1, 0 is going to go 1 minus 3. So negative 2, negative 0, minus 2. Okay, the next coordinate is going to become negative 5, positive 1, subtract 2. And then can you write the last one yet? Reflection right, or no, sorry, reflection left and down, right? So everything you see? Okay, number 13, I don't like it. This would be a common mistake on a test. What's the thing I don't like right now? The factored out. It's not how it should look. That is how it should look. Okay? So now my math coordinate is nothing with the y's. my new coordinates. So -0 plus 2. -2 plus 2. -4 plus 2. -5 plus 2. So graph it and see if it is looking like you think it should with your descriptors. On graphs, if I have arrows, you have arrows. If I have points, you have points. It should have reflected over that x or over the y-axis, and it should have gone right. Did I graph something wrong? Yeah, I did. There we go. That one was wrong. Does mine look the same as yours? All right. Okay, graphing the original functions, and oh man, then we're done. Okay. Graph the original function. Okay, so we had an original, and then what did we do? We would have gone x to y. What are we going to do working backwards? The y's are going to get divided by 2 now. And the x's didn't change. So we're going to get 5, 5. We're going to get 4, 3. We're going to get 2, 3. And we're going to get 0, 1. Does this make sense that now this is the original, and if you were to vertically stretch it by 2, it looks like that. Okay, and the last one here. So this time I would have done that. If I had started at the original, I would have done that, which is the same thing as doing that. But now I got to figure out how to go backwards. So here I better be dividing x by 2 to go backwards. So 0, 1 stays. That becomes 2, 3, 4, 3, and 5, 5. So if this was my original, think about horizontally compressing it by half, which is physically the same as horizontally stretching it by 2. So that's what we ended up with.